This is SpaceTime Series 28, Episode 115, for broadcast on the 24th of September 2025. Coming up on SpaceTime, the exoplanet count passes 6,000, decoding Venus's mysterious surface, and the growing tale of interstellar comet 3I Atlas. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have just confirmed their 6,000th exoplanet, that is, a planet orbiting a star other than the Sun. The new milestone highlights the accelerating rate of discoveries made in the 3 decades since the first exoplanet, the hot Jupiter 51 Pegasi, was detected way back in 1995. Confirmed planets are added to the count on a rolling basis by astronomers around the world, so there's not a single planet which is actually considered as the 6,000th entry. The numbers monitored by NASA's Exoplanet Science Institute, which is based at Caltech in Pasadena, California. As well as the 6,000 confirmed exoplanets, there are more than 8,000 additional candidate planets still awaiting confirmation. NASA's Astrophysics Division Acting Director, Sean Donegal-Goldman, says the historic milestone represents decades of cosmic exploration that's completely changed the way humanity sees the night sky. Instead of just seeing the stars up there, we now know there are planets orbiting those stars. Still, although researchers think there are probably billions of planets up there in the Milky Way galaxy, finding them remains a challenge. In addition to discovering many individual planets with fascinating characteristics, as the total number of exoplanets climbs, astronomers are also able to see how the general planetary population compares to planets in our own solar system. For example, while our solar system hosts an equal number of terrestrial or rocky planets compared to gas and ice giants, rocky planets appear to be far more common around other stars. And astronomers have also found a range of planets entirely different from anything seen in our solar system. Of course, there are the Jupiter-sized planets known as hot Jupiters, gas giants whose orbits are closer to their host stars than Mercury's orbit is to the Sun. Then there are planets that orbit 2 stars, rogue planets wandering through space, not orbiting any star at all, planets orbiting dead stars, planets covered in lava, some with a density of styrofoam, and others with clouds made of gemstones. Each of the different types of planets discovered gives astronomers new information about the conditions under which planets can form, and ultimately how common planets like the Earth might be, and where scientists should be looking for them. But despite the thousands of discoveries now made, fewer than 100 exoplanets have actually been directly imaged. That's because most planets are so faint they get lost in the bright glare from their parent star. And the other 4 methods of planetary detection are all indirect. With the transit method, for example, astronomers look for a star to dim for a short period as an orbiting planet passes in front of it. To account for the possibility that something other than an exoplanet is responsible for a particular signal, most exoplanet candidates need to be confirmed by follow-up observations, often using additional telescopes. That takes up time. Then there's the wobble method, where the mass of an orbiting planet causes its host star to slightly wobble off-center, something which can be picked up by the star's Doppler shift. The rate of exoplanet discoveries has been accelerating in recent years. The database reached 5,000 confirmed exoplanets just 3 years ago, and this trend seems likely to continue. In fact, astronomers expect to receive thousands of new exoplanetary candidates thanks to the European Space Agency's Gaia mission, which finds planets through a technique called astrometry. And also, of course, there's NASA's upcoming Nancy Grace Roman Space Telescope, which will discover thousands of new exoplanets, primarily through a technique called gravitational microlensing. At NASA, the future of exoplanet science will emphasize finding rocky planets similar to the Earth, and then studying their atmosphere for biosignatures, that is, any characteristic element, molecule, substance or feature which can be used as evidence of past or present life. NASA's Webb Space Telescope has already analysed the chemistry of more than 100 exoplanetary atmospheres. But studying the atmospheres of planets the size and temperature of the Earth will require new technology. Specifically, astronomers need better tools to block out the glare of the star the planet's orbiting. And in the case of a small Earth-like planet, that glare will be significant. Put it this way, the Sun is about 10 billion times brighter than the Earth, and that's more than enough to drown out our home planet's light if it were being viewed by a distant observer. NASA currently has two main initiatives to try and overcome this hurdle. There's the Nancy Grace Roman Space Telescope. It'll carry a technology demonstration instrument called the Roman chronograph that will test new technologies for blocking starlight and making faint planets more visible. At its peak performance, the chronograph should be able to directly image a planet the size and temperature of Jupiter orbiting a star just like our Sun, and at a similar distance from that star. With its micro-lensing survey and chronographic observations, Nancy Grace Roman will reveal new details about the diversity of planetary systems, showing how common they are, and how many are like our own solar system across the galaxy. Of course, additional advances in coronagraph technology will still be needed in order to build a coronagraph that can detect a planet the size of the Earth. And NASA is working on the concept for just such a mission, currently named the Habitable Worlds Observatory. This report from NASA TV.
The stars above. What secrets do they keep? One of our biggest questions has always been, are we alone? We've now discovered thousands of planets beyond our solar system, but how many of those distant worlds have the conditions for life as we know it? How many have water vapor, a beacon indicating that oceans might be present? How many have gases like oxygen and methane, possible signs of life itself? And of those, which might truly have life? After decades of asking, a future NASA telescope could bring us the answers. The Habitable Worlds Observatory is a future mission designed in the tradition of the Hubble and Webb space telescopes. It will use its unique and sensitive eyes to see planets like our own, hiding in the light of their distant stars. Astronomers could then point this mighty space observatory to the most promising planets, those that may hold liquid water. With the help of its coronagraph instrument, which blocks out the dazzling starlight, the telescope will look for undiscovered Earth-sized planets in the star's habitable zone where liquid water could exist. The light from each planet will be split into a vibrant spectrum of colors, revealing clues to the chemical signatures we seek. From there, we can attempt to discover if a planet's atmosphere contains water, and from there, other signals like oxygen or methane. Should all these signs align, the Habitable Worlds Observatory would delve deeper to reveal other hidden clues of life. With further study, we could find signs of sprawling oceans and rugged continents. And if signs of life are revealed, keep a watchful eye for changes over time. This magnificent observatory could discover dozens of worlds akin to our own in its first 5 years. The telescope will gather data on a wide variety of worlds, placing our own solar system in the context within the grand tapestry of existence. And the Habitable Worlds Observatory will, like the other great cosmic watchers, Hubble, Chandra, Spitzer, Webb, and soon Roman, also conduct a wide range of revolutionary observations of our cosmos, improving our understanding of how our universe led to potentially habitable worlds. Thus, the Habitable Worlds Observatory will help us embark on a quest as grand as any to tell the story of life in the cosmos, and whether or not we are alone.
This is SpaceTime. Still to come, decoding Venus's mysterious surface and the growing tale of interstellar comet 3I Atlas. All that and more still to come on SpaceTime. Scientists trying to understand the weird surface features of the planet Venus may finally have come up with an explanation for at least some of this strange world's geography. Venus's surface is pockmarked with round, crown-like features known as coronae. These more or less circular structures can look like terraced hills pushed upwards by heat energy, or like collapsed soufflés, shrunken as supporting materials beneath them cool off and contract. And these weird features, which can vary in size by up to tenfold, are unlike anything seen on Earth. Now, a report in the Journal of the Proceedings of the National Academy of Sciences suggests that coronae are most likely caused by plumes of magma trying to burst through the planet's crust. The study's lead author, Madeleine Kerr from Scripps Oceanography, says one value of studying Venus is understanding what's happened there which makes it unable to support biological life, while life flourishes here on its sister planet, Earth. Venus is the closest planet to the Earth. The two worlds are roughly the same size, they were formed out of the same material in the same part of the solar system, and under similar conditions. Yet while Earth has become a habitable world with abundant liquid water and life, Venus has become a hellish landscape with vast larval plains where surface temperatures can reach more than 460 degrees Celsius and a thick carbon dioxide atmosphere where pressures are some 99 times heavier than that at sea level on Earth, thanks to a vast planet-wide 80-kilometre thick blanket of clouds which acts like the lid of a pressure cooker. Now, like Earth, it does rain on Venus, but the rain isn't water, it's sulfuric acid, and metallic snow covers the Venusian mountain peaks. Even stranger, Venus rotates backwards with the sun rising in the west and setting in the east. A day on this weird world lasts some 243 Earth days, which is longer than a Venusian year, which takes some 225 Earth days. To reach their conclusions in this new study, the authors mapped the paths of bursts of magmatic energy pushing outwards from Venus's core some 3,000 kilometres below the crust. Unlike Earth, which has moving tectonic plates caused by the convection of heat from deep below, Venus has just a single rigid crust covering its entire surface. So the heat has no way to escape. Hot upwellings, like the blobs that rise in a lava lamp, can push through from the core, creating massive 2,000-kilometre wide volcanic structures. But many of these hot channels of magma don't have enough energy to punch through the crust. So when they approach the surface, say 600 kilometres below, they're blocked by a layer in the mantle which forms due to changing crystal structures in the rock, creating what the authors term a glass ceiling effect. After some of these hot rocks are blocked, even smaller blobs can rise up towards the surface from this shallower layer. And it's these smaller blobs which may form the abundant and small coronae features often seen scattered across the Venusian surface. This is SpaceTime. Still to come, the growing tail of interstellar comet 3I Atlas, and later in the science report, a new study confirms that daylight savings really is unhealthy for you. All that and more still to come on SpaceTime. Astronomers have obtained a striking new image of the growing tail of the interstellar comet 3I Atlas. The observations are revealing what is now a prominent tail and glowing coma from this rare celestial visitor. It's also providing new scientific spectroscopic measurements, allowing scientists to get a better idea of its composition. To do this, the authors used the Gemini multi-object spectrograph on the Gemini South Telescope in Chile. The observations uncovered a broad coma. That's the cloud of gas and dust that forms around the comet's icy nucleus as it gets closer to the sun. They also saw a tail spanning some 1/120th of a degree across the sky, pointing away from the sun. Now, while these features were there before, they're now significantly more extended than they appeared in earlier images of the comet. And that shows that Comet 3I Atlas has become more active as it's travelling through the inner solar system, getting closer to the heat of the sun. The comet was first detected back on July the 1st by the Atlas Asteroid Terrestrial Impact Last Alert System. The new observations suggest that the dust and ice of 3I Atlas are broadly similar to those of comets from our solar system, and that hints at shared processes for forming planetary systems around other stars. The observations examine the comet's spectra, which provides clues about its composition and chemistry, as well as the size of dust particles in the coma. But the growth of the tail also suggests a change in the particles from previous Gemini images. Interstellar comets are extraordinarily rare. 3I Atlas is only the third confirmed example, after Comet 1I Oumuamua back in 2017 and Comet 2I Borisov in 2019. Unlike comets from our solar system, which are bound to the Sun, 3I Atlas is travelling on a hyperbolic orbit that will eventually carry it back out into interstellar space. But its brief passage through our solar system gives astronomers a once-in-a-lifetime opportunity to study material that formed around a distant star. The comet's about to disappear behind the Sun, but it will re-emerge in November when more observations will be made. Needless to say, we'll keep you informed. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. Every spring, Americans and most Australians dutifully adjust their clocks forward to daylight savings time. And every autumn or fall, they adjust them back to standard time. The problem is no one really seems very happy about it. This biennial time shift is not only inconvenient, it's also known to be acutely bad for human health, and has been linked to heart attacks and fatal traffic accidents in the ensuing days. Now, a study by Stanford medicine researchers finds there are longer-term hazards as well, and better alternatives. The authors compared how 3 different time policies, sticking with a permanent standard time, permanent daylight savings time, and the current biennial shifting, could affect people's circadian rhythms and in turn their health. The authors found that either permanent standard time or permanent daylight savings time would be healthier than the current seasonal wafting, with permanent standard time benefiting the most people. They also found that by modelling light exposure, circadian rhythm impacts and health characteristics across the United States, they could estimate that permanent standard time would prevent some 300,000 cases of stroke every year, and it would also result in some 2.6 million fewer people having obesity. The findings, reported in the journal The Proceedings of the National Academy of Sciences, also show that permanent daylight savings time would achieve about 2/3 of the same effect. Paleontologists have identified a new species of dinosaur based on a fossil which had been sitting in a museum drawer for more than 125 years. Scientists from the University of Bristol officially identified the new species, Newtonosaurus zanclodon cambriensis, as a large predatory theropod dinosaur. A report in the journal The Proceedings of the Geologists Association says the half jawbone section is some 28 centimetres long, so originally the full jawbone would have been around 60 centimetres in length, corresponding to a dinosaur with a body length of up to 7 metres. And this would have been unusually large for a Jurassic period theropod, most of which were only about half that size or even smaller. The authors reached their conclusions using modern digital three-dimensional scanning techniques to shed new light on the fossil jawbone, which was dug up in 1899 from the Triassic fossil beds of South Wales. It had been on display at the National Museum of Wales for many years, but had not been correctly identified until now. A new study has shown that artificial intelligence can now determine which young adults need treatment to prevent vision loss. The findings, reported at the 43rd Congress of the European Society for Cataract and Refractive Surgery, looked at people with keratoconus, a visual impairment that generally develops in teenagers and young adults and which tends to worsen in adulthood. The authors used artificial intelligence to assess images of patients' eyes and, combined with other data, successfully predicted which patients needed prompt treatment and which could continue with simple monitoring. They found the AI could predict accurately whether a patient's condition would deteriorate or remain stable, simply using images and data from just one visit. Using AI, the authors could sort 2/3 of patients into a low-risk group that didn't need immediate treatment, and the other 1/3 into a more high-risk category who needed prompt attention. In Australia, the final countdown is now underway to the federal government's introduction of what will be a forced digital identification scheme for access to social media. The legislation comes into force on December the 10th. Now, the government claims it'll protect kids under 16 by preventing them from accessing social media and YouTube. But what it really does is that it will force you to prove that you're over 16 to access those sites. That means supplying often foreign-based media companies with your personal details or biometric information, which, despite whatever assurances they give you, past experience has proven will end up with your digital ID being traded to other parties or hacked and sold on the dark web. It also provides the government with what they've always wanted, an Australia card-style digital ID for every citizen, allowing politicians and bureaucrats to link your medical records, your driver's licence, your tax file number, financial details, your criminal names index, if any, as well as addresses and contact information, all in the one file. It means the arrival of an Orwellian 1984-style Big Brother. And that's being seen by some as the first step towards a Chinese government-style social credit scheme, in which the government will always know what you're doing, where you are, and be able to control what information you get, what services you have access to, even what schools your kids can attend. And again, that's happening right now in China. And before you say that could only happen in a totalitarian communist dictatorship like China, well, similar digital ID records in Canada were used recently to freeze protesting truck drivers' access to their own bank accounts. And here in Australia, despite assurances by the government, police use the COVID ID passport scheme to track people's whereabouts, find out what they've been up to. Big brother indeed. But the public is fighting back. People are already starting to use more and more VPNs and anonymous browsers such as Tor. With the details of where we're likely to go, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
In July this year, the UK had their own age verification system where people needed to be verifying their age to get online to services like X or Reddit or some of the porn websites. And when that happened, VPN software became the most downloaded on the App Store in the UK. And VPNs obviously allow you to change the location that you appear from. And people are clearly using them to bypass these requirements of the Online Safety Act. And that's human nature. Governments want to impose something, and people, like water trying to find the easiest path, are going to flow to things like VPNs to try and get around these particular restrictions. We've seen this in China. I mean, China had VPN blockages and bans years ago, but people in China still use VPNs to this day to get access to Western services, to get access to Google. And, this is just what's going to happen. The government wants to do something to restrict freedom, and people are going to want to do something else to get their freedom back. So we've already seen what happens in other countries, and there's no reason to think that exactly the same sort of thing won't happen here in Australia.
That's Alex Zaharov-Reutt from TechAdvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.